far as the systems go, you're simply going to have equations that fit the following form. And so you're going to have two equations. There will generally be two unknowns in each equation, but there will be two unknowns involved in the combined two equations. And your solution must fit both equations. And so when you're looking for a system of equations, basically what you're looking for is the intersection of two sets of solutions. So it's the ones where they both fit, or they both are solutions. And so one way to look at this is to solve by graphing. And if you are solving by graphing, basically what you do is you sketch your graphs, you try to find out where the intersection point is, and that is your solution to both equations. Okay, so if I gave you an example of the following. Okay, so here's your system. You're given two equations with two unknowns. And the easiest thing, again, you can use intercept form, which these are both written in that intercept form, where you can just say, well, if y is 0, what would x have to be for the first equation? 1. And if x were 0, what would y have to be? -1. So you can find the intercepts that way if you want. You can also begin by putting each of these into slope-intercept form. Okay, how many of you guys would use the intercept form? Just type in the zeros and see. Okay, you can do that. I'm going to show the other form of y-intercepts simply because we're going to put these into our calculators, and in order to put it in the calculator, we need to write it in the y-intercept or the slope-intercept form anyway. So I'm going to convert both of these into slope-intercept form. You can do it by hand. It should be relatively easy for you to do that. So if you put this in slope-intercept form, we take equation 1 here, and we solve for y. We need to subtract an x from both sides, and then change the sign of every term. So we get positive y is equal to positive x minus 1. So there's the slope-intercept form. If we sketch that graph, we have our y-intercept at -1, and we move up 1 over 1. And so we can sketch the line that accompanies that graph, or that accompanies that equation. And now for the second equation, again, to solve for y, we simply move everything over to one side. So we subtract a 2x from both sides. So we go down 1, 2, 3, 4, bless you. And we move up a slope of up 2 over 1. Okay, and so we find our intersection is going to be right here. Now, it's not always going to be the easiest thing to see the intersection. If you're using graphing paper, you can. If you're using your calculator, you can, which is why we'll do that as well. If you're just sketching it, it's harder to see. What does it appear this solution point would be? It appears that it's an x-coordinate of -1 and a y-coordinate of -2. Okay, so that's what it appears to be. What you can do to check your solutions is you can plug that set of points into your original equation. So let's test it. Let's plug a -1 in here. Is it true that -1 minus a -2 is equal to 1? Yeah, so that one checks on the first equation. Let's plug it into the second. Is it true that 2 times a -1 plus a -2 is equal to -4? -2 minus 2 equals -4. So it checks on both of those, so that is your solution point.